Okay, so I will share some questions which we were supposed to do it, and you can start quickly, and then we can go for miscellaneous problems in K-maps, and we'll do some problems on no number systems. Can you guys see my screen? Can one of you confirm it? Very nice. Okay. Okay, we want to solve problems, right? Yeah. Quickly solve these problems. Yeah, based on whatever we discussed last week, two numbers are represented in signed 2's complement form, or P is this, Q is this. If Q is subtracted from P, the value obtained in 2's complement form is dash. Q is 11100 110. See, I'm sharing the answer. These kind of problems, no, very simple technique is we are very comfortable with decimal number system, right? Decimal numbers. Try to convert it into decimal numbers and then see what is P. So, to know what is P, right, first of all, you need to observe this MSP. If you look at this MSB, this is 1. That means that P is negative number. Look at this is also negative number. Yeah, let's see. Somebody is saying option A. So what is that they have done? The value like Q is subtracted from P, correct? Q is subtracted from P. P minus Q, they did. Okay. Now, how to get what is P in decimal? What exactly is P? We know already, if at all, like let's say for example, I'll take number 4. Okay. You know the binary equivalent is 0, 1, 0. If at all I want to have minus 4, what I should do? I'll take 1's complement and then add plus 1 to this, right? 0, 1, 1. And this is a 1's complement. This is a 2's complement of minus 4. Now, my question is they gave this. You need to find out what is this value. What is this x? Now, let's see. Suppose if I do 2's complement on this, what will happen? I'll take 1's complement on this, like 0, 0, 1, 1. By looking at this number, I know it is a negative number. That is very clear. I'm trying to find what is the magnitude. I got 1's complement and add plus 1 to this. What will happen? 1, 0, 1, 0, 1, 0, 0. That is 4, correct? And I know this is already negative number. So I know this number is minus 4. Similarly, you can do same thing. Very easy. Hmm? You know already P, right? And that's a negative number, right? P is negative number. We know the number is 1, 1, 1, 0, 1, 1, 0, 1. You find the 2's complement of this to get origin. I know this is negative number. P is some negative of something. I'm trying to find the amplitude. I mean magnitude of it. So find 1's complement, add 1. 0, 0, 0, 1, 0, 0, 1, 0. Add plus 1 to this. What will happen? 1, 1, 0, 0, 1, 0, 0, 0. What is this? How much is this value? 1, 2, 4, 8, 16. So 16 plus 2 plus 1 is 19. P is minus 19. Somebody says. Right? Similarly, one can find out Q. What is Q in decimal? Very easy. Because MSB is 1, I know this is Q is also a negative number. But what is the magnitude? That for that I have to find 2's complement. For that I have to do 1's complement and add 1, right? Let me take 1's complement. 0, 1, 1, 0, 0, 1 plus 1, right? 1, 0, 1, 0, 1, 1, triple 0. Okay, so what is its value? This is 1, 2, 4, 8, 16. 16 plus 8 is 24. 24 plus 2 is 26. Q is minus 26. Now what is that they are saying? Q is subtracted from P. If you subtract Q minus 19 minus of minus 26 is nothing but what? Plus 7. Plus 7 is what? See, you can see this. This is 1 means this is a negative number. This is MSB is 1 means this is a negative number. MSB is 1 means this is a negative number. Obviously, only one answer is there. Even if you see, this is 7, right? So option B is right answer. And this is a gate question, by the way. Most of the problems what we are 99% are gate problems, okay, whatever we are solving. Right? So like this, there are multiple questions. I request you to go through all this. Um, so like this, there is one question. Okay, there are many questions on 2's complement. I have written like this, right? So please go through this. If at all you have any questions, you please ask me, or we can do a separate session. Okay, I can do one thing. I can work it out till 5:20. Okay, let us solve how many we can solve, and then we'll move to K maps. Right? Solve this problem quickly. You should do 1, 2, 3 base x is equal to 1, 8 base 10. Then x is what? Okay, any answers? Uh, okay, option B. So you know what is the decimal already decimal equivalent you know on the right hand side. Left hand side, how to do that? 3 into x power 0 plus 2 into x power 1 plus 1 into x power 2. It is a decimal equivalent that is equal to 18 because this is also a decimal equivalent, right? So x square plus 2x plus 3 is 18. That means that x square plus 2x minus 15 is equal to 0. So how to find those roots? Okay, you know that, no? Like minus 15, I can split as 5 and minus 3. So x square plus 5x minus 3x minus 15 is equal to 0. X into x plus 5. This, no, you know the story, right? X plus 5 is equal to 0. X plus 5 into x minus 3 is equal to 0. The roots are either x equal to minus 5 or x equal to 3. So, and radix, can radix be negative? Can radix be negative? No, it's impossible. Radix cannot be negative. So it's ruled out. Now what is the other option? 3. So 3 is also not right answer. Answer is none. You know why? Suppose if you take that 3 exists, 10, 1, 2, 3, base 3. Does this exist? No. If you take decimal number system where radix is 10, what is the maximum number? 0, 1, 2, and up to so on 9, right? We already discussed maximum number is r minus 1. So 1, 2, 3, base 3 doesn't exist. So obviously this number system doesn't exist. Okay, so the answer is no. Right? So hmm, these are all simple problems. You can, if you can try on your own, you may get it. Okay. Okay, try this. 43 base x is equal to y3 base 8. You need to find what are the possible solutions. The number of possible solutions for x and y. 43 base x is equal to y3 base 8. Try to find the decimal equivalents of both the sides and then equate them. That will give you number of possible solutions. And intuitively you have to think there. Right? So anybody tried? You convert into decimal equivalent? Yes. What is the answer? So decimal equivalent of this is what? Okay. X equal to 0 possible है क्या? See, you are writing 4, 3 base x. X should be always greater than 4, right? That is the logic. If I write y3 base 8, y is always less than 8, correct? So let me solve it for you. Like, you know, 3 into x power 0 plus 4 into x power 1 will make it decimal equivalent. On the right hand side, same decimal equivalent is 3 into 8 power 0 plus y into 8. Correct? So 3 3 gets cancels. 4x is equal to 8y. X equal to 2y. It looks like infinite solutions exist but doesn't. Why? Because the condition is here. You see this, x must be greater than 4, y must be less than 8, right? So if I take y equal to 0, let's say y equal to 0, then x will become 0 because 2 into 0 is 0, right? If I take y equal to 1, x equal to 2, correct? X equal to just 2y, right? 2 into y. This doesn't solve because x should be greater than 4. Then you take y equal to 2, then x equal to 4. This also not a feasible solution. Then y equal to 3, x equal to 6. Is it okay? Yes. Then y is equal to 4, x equal to 8. This is also okay. Then y is equal to 5, then x equal to 10. This is also fine. Y equal to 6, x equal to 12. This is also fine. Then y is equal to 7, x equal to 14. This is also fine. Right? Then can I take y equal to 8? No, because the condition is already y should be less than 8. How many possible solutions? 1, 2, 3, 4, 5. 5 possible solutions. So option C is the right answer. Clear? Hey, you join first on time, okay? You are joining now and asking, can you join? Can you explain again once again? What is this, man? Okay. You watch the recording, okay? Recording is available. Later you can watch. We are running out of time. So, okay, next problem. This problem has been given many times. 4-bit 2's complement of decimal number is 1000. The number is dash. This is the last problem. After that, we will move to K-maps. So, very simple, straightforward. Correct. 2's complement representation they have given as 1000. Looking at this, I know this number is going to be negative. How to find the magnitude? You again do the 2's complement. So take 1's complement on this 0, 1, 1, 1 and add plus 1 to this. 1, 1 is 1, 0, 1 plus 1 is 2, 1, 0, 1 plus 1 is 2, 1, 0. This is 1, right? So what is this magnitude? 8. Correct? So option D is the right answer. That's all. That's simple it is. I don't know. So many times they give. So, okay, something similar. Many questions. We are running out of time. There are many tricky questions in this. So if anybody wants to solve all this, you can just solve it. I mean, I can mail, I can ask me. I will share the all these questions. I think some people I have shared it in the last week. Please go through and then ask me, over mail if at all you need anything else. Right? So now let's move to K maps. Yes. Okay. This is the first question. Number of essential and redundant prime implicants are dash. Any answers? Number of essential and redundant prime implicants are. Either A or D. No, no, this is not multiple choice question. Okay. Multiple answer type. It's not multiple answer type. Only one answer. Okay. What I have done is, if you look at the chat, I have shared one YouTube link. Can you guys see that? I hope so, right? Everybody can see. So that video talks extensively about how min terms, max terms, and everything is derived, right? So before going further, what I thought is, I think we will discuss little more about that. Okay, you just go through that. That extensively talks. If I miss some of the points now, you may find it in that video. It's a 20-minute video or everything about how min terms are derived, maxims are derived, and all those things. Okay, I'm just going to give you that only right now. If at all, if you think something else you need to do, just go. Hmm. Yes. Is it? Uh, okay. All right. Done. Can you confirm me right now? Can you see? Yeah, no problem. Just understand this. This is so easy. I'm telling you. The min term, max term things. Let's say I have this function f, and I can have four combinations, right? You can derive this along with me. You don't need to worry much. Let's say there is some function like this. You know this function. This is called XR function. But right now you think that you don't know about that name and all those things. Okay. So if at all I want to write f in terms of Boolean expression, see, if what happens is this is the table. This is called truth table, right? You will get the truth table and they will ask you to realize it. Realize it means in terms of AND gates, OR gates, and all those things. Okay, how to realize it in a hard way, right? That's a realization. So why are we doing all Boolean algebra and all? So that we can use less number of hardware, okay, as much as possible, correct? And then we will develop, right? That's how Boolean algebra techniques and K-map techniques and all will come into picture. Suppose what will I write? F is one. You look at F is one when A is zero, B is one, right? F is 1 when A is 0 and B is 1. A is 0 and B is 1. How to write whatever I said verbally in terms of logic? Can I write like this? A is 0 means A complement and B is 1. Whatever I said verbally, I can write like this. You put A equal to 0 and B equal to 1, you will get F is equal to 1. Or if A equal to 1 or or if A equal to 1 and B equal to 0, then also F is equal to 1. R means R operation, right? A equal to 1 and B equal to 0. Okay. Looks like these are called min terms. This is min term. Or this is a product, correct? This is product. This is also product. What is this? Looks like sum, right? So sum of products, that's it. This is also called SOP or canonical SOP form. Means this form should have all the variables, all the input variables. Now, you see this min term is confusing, right? You need to give numbers because there are so many min terms that are possible. Just we took only two variables. That's why only four min terms are there. What if I take 100 variables? So many are there. So we should number it. How to number them? Very simple. right? This is min term represented by small m. 0, 0, 0, 0 in binary. Let's say, what is it in decimal? 0, right? I write min term 0. 0, 1. This is AB if I take in this order. Very, very important. If I take BA, then everything else is changed. I am taking A as MSB, right? I am making my point very clear. A as MSB, B as LSB, right? Then what is 0, 1 equivalent in decimal? 1, correct? So this is min term 1. This is min term 2. This is min term 3. Right now, when I write f of AB, when I'm doing computer operations and all, I don't need to write A bar B and all those things. I know already A is MSB, B is obviously LSB. So what is this min term number? M1. This is min term number M2. So f of AB is just M1 plus M2. That's it. Okay, later we will see how to write, how to simplify and all. This is just format, one format, like SOP form. This is what is called canonical SOP form. Now, f of AB, one more way you can write is, this is a sum, right? Looks like sum. What is the symbol for sum in mathematics? Sigma, right? Sigma. How many sums are there? Min term 1 and min term 2, right? Just I write 1, 2. That's it. Correct? Now, some people think that, sir, why you are biased? You are only focusing on ones. Alright? Now, what I can also write is, you look at the other one. I can also write M0 plus M3. Correct? Now, here, this is 0 actually. Means I'll just put a complement here. This is also F. Right? That means what did I write? I'll just, what did I write is very simple thing. Okay? Just focus on this point. I write A bar dot B bar, similar to whatever we have done, plus AB. What I did a complement. Now you take, let's say for example, you take A equal to 1, B equal to 1. This should give you F is equal to 0. Let's see whether it is coming here or not. If I put A equal to 1, B equal to 1, what will happen? Complement, 1 complement and 1 complement plus 1 and 1. And you know this is 0, this is 1, 0 plus 1 whole complement, 1 complement, that is equal to 0. That's it. So simple. Whether I can write in terms of ones or whether I can write in terms of zeros, how does it matter? Finally, the logical value is matching, right? Right? So, this f can be written as what? This is min term 0, this is min term 3. So, m0 plus m3 whole complement. So, f is what? m0 complement. We know De Morgan's law already. m3 complement. So, f is m0 into m3. Now, if you go inside of this and then further expand in terms of ABs, M0 is A bar dot B bar whole complement, A dot B whole complement. What is this you will get? A plus B into A complement plus B complement. This is M0, capital M, this is capital M3. Okay. So if I write A equal to A bar B plus AB bar, this is also right. Or if I write F is equal to A plus B into A bar, that is also right. If I write F is equal to M1 plus M2, that is also right. Or if I write F of AB is equal to M0 multiplied by M3, that is also right. So F of AB can be written as M1 plus M2 or capital M0 into capital M3. Everything is right. Okay. Right. Now, there's so many names, okay, on the right hand side. Right hand side, what is there if you see? This is sum, right? This is also sum. And there is a product. So product of sum, POS. And you see this f of AB is equal to M0 into M3 multiplication. What is the symbol for multiplication mathematics? Pi, right? Capital M of 0, comma 3. I can analyze f in this way or I can analyze f in this way. Doesn't matter. This is SOP form, canonical SOP form. This is canonical POS form. Hmm? So this is canonical POS form. This is canonical SOP form. And if you look at this, you see this. If you look at canonical SOP, you have minterm 1 and 2 in this, right? You see this here. Minterms 1 and 2. And if you look at canonical POS for the same function, max terms, these are called max terms. Okay, the right hand side, left hand side are called minterms, right hand side are called max terms. And if you look at the right hand side, right, 1 and 2 are present. That means that 1 and 2 will be absent in the max terms. That's obviously, you know that why it will be absent. This is the derivation, right? This is how the things are derived. Is everyone clear with this? Can somebody say yes or no? No? Can you guys hear me? Okay, all right. So now the thing is, for example, now you know all these concepts. Okay, I will. There are many questions based on this slide. Okay, if you know this slide, understood this slide very clearly, uh, that's enough. Okay, I'm leaving it to you why they are called min terms and max terms. Just think about it and let me know in the next week. I already told in the video. You let me know anyways. Suppose if I give you this function f of AB is equal to m1 plus m2 and I'll ask you to write it in terms of canonical form or in terms of boolean variables a and b. What will you write? This is 1, correct? This is 2. What did we do? You convert this into binary. In terms of how many variables are there? 2 variables. So 2-bit binary numbers you have to take. 1 is converted as 0, 1 in binary, correct? 2 is converted as 1, 0 in binary. Because this is 0, you see this. Because 0 is there, you got A complement, right? Because 1 is there, you got uncomplemented form. Similarly, first variable is A, second variable is B. MSB is A, right? So I should write A in the complement form, B in uncomplemented form, and obviously plus is there, A is there, B bar is there. It's also straightforward, right? Simple. Decoding it back. All right. So now I just want to give some establishment here, so that's why I explained about canonical, SOP and POS. Now there is something called as K-map come into picture, right? That we know. Okay, just a minute. I'm just adding these people. Now, what is that K-map in simple terms if we write? Let's say there is a function f ABC plus ABC bar, correct? Now I can simplify this like this: AB into C plus C bar is equal to AB. That's all, right? You have C and C. Now, same thing we can do it in terms of numbers also, right? Now, if I write minterm representation, this is 1, 1, 1. This is 1, 1, 0. This is nothing but M7 plus M6. right? And this can be written like AB, correct? If you look at these two minterms, they differ by, like one is 111, this is 110. What are these called as? Gray codes, correct? Similarly, okay, we have set of rules in the K-map, right? And then we'll try to figure out, okay, what is that, what is this, and all those things, right? So if you write F is equal to, let's say for example, AB plus A bar C plus BC, okay? Now, can anybody tell me what is the simplified version of this? Simplified form of this? Yeah. How is that? Redundant term, right? Yes. Okay. Yes, BC is redundant. Okay, consensus. Now we will connect the K map to consensus. Then we'll understand that, right? Now, let's say for example, F of A, B, C. This is AB plus A bar C plus BC. Can I convert into canonical form? Canonical form. By the way, whatever the steps that we are doing, all are gate questions somewhere here and there. By the way, next week also came up miscellaneous problems. Lot of problems are there. Don't worry. Okay, we have everything to twist you, and then you will become expert in that. Now, to say it is canonical form, in this product, let's say AB, C is missing, right? In this product, B is missing. In this product, A is missing, right? So how to do that? I write AB as AB into 1, and then I can write AB into, this is C plus C bar. That means this is ABC plus ABC bar, right? So I can write ABC plus ABC bar. Similarly, I can write A bar BC plus A bar B bar C. Let me know if I do any mistake here. Then A bar BC plus A B C. Hmm? F of this is A, B, C. Now I have to write in terms of min terms, right? So uncomplemented form means A is 1, B is 1, C is 1, 1, 1, 0. This is 0, 1, 1, 0, 0, 1, 0, double 1, 1, 1, 1. We have max terms exactly in the reverse way. If there is uncomplemented form, there is 0, then otherwise it's. So what is this equivalent? 7, right? M7 plus M6 plus M3 plus M1 plus M3 plus M7, right? Now these are repeating. Okay, we know already A plus A is A, right? In Boolean algebra. So M7, okay, I will write from lower to higher, right? We have M1 plus M3 plus M3 is M3, M6 plus something, nothing is there. M7 plus M7 is M7. Okay. Now first you need to get into this canonical form to go for a K-map. So what K-map says is very simple. K-map rules, three variable K-map, and I'm sure most of you know the rules. I no need to repeat them. It's a gray code rule, right? We have to form a gray codes. 0, 0, 0, 1, 1, 1, 1, 0. Right? Then where is M1? This is 0, right? This is 0. This is MSB, na? A is MSB. C is LSB, right? So this is like 0, 0, 0. This box is like 0, 0, 0. What is its equivalent? 0, right? So this is M0 box. This is M1 box. This is M3 box. This is M2 box. Then M4, M5, M7, M6, right? So now somebody may say, sir, why not? This is like what? Canonical SOP form, right? This is canonical SOP. Can I do canonical POS? Absolutely yes, no problem. Be with me for next one more week. We will be very clear about this. Now, in this, we have to locate where f is 1, m1 at the place here, it is 1. Then m3, here also it is 1. m6, here it is 1. m7 is here, it is 1. Right? So, basic rule of Carnoy map is, right, you try to group, you need to find a group of maximum numbers, like group of 8, group of 4, group of 2. If nothing is possible, 1. If there are 4 variables, group of 16 ones. All right, so let me start grouping it. So what I can do, either I can do horizontal grouping or vertical grouping, and there is no diagonal grouping allowed. Okay, I cannot do that because they don't form a gray code. They don't form a gray code. As long as they form a gray code, you see this. This is 001. This is 011. They form a gray code. That's why I'm grouping M1 and M3. M3 and M7. M3 is 011. M7 is 111, right? So I can again form the grouping. But I cannot do M1 and M7, right? M1 is what? 001. What is M7? 111. Okay, this is not a gray code, so I cannot group it. Are you getting it? So now here, first question you need to ask is group of 8 ones possible? No. Group of 4 ones possible? No. 8 ones, 4 ones, not possible. Group of 2 ones? Yes. Now I can group like this. I can group like this. I can group like this. So this is called as pair. This is first pair. This is second pair. This is third pair. Hmm? So what is first pair corresponding to? In this pair, A is not changing, C is not changing, B is changing. So leave B. Whatever is changing, you leave it. What is not changing? A is not changing, C is not changing. Value of A is 0, that means A complement dot C. Second pair. Okay, this pair, second pair, this one. Okay, A is changing in these two columns and in these two rows. So leave that. B and C are not changing. B value is 1, so B. C value is 1, so C. The third one. Right? Third one is this. This is the third one. And A is not changing, so A. In these two, B is not changing, so B. Now here comes the ultimate for K-maps. So what should I write? What is F? Is it 1 plus 2 plus 3? Or 1 plus 3? Or 2 plus 3? Who will decide? Or 1 plus 2? So remember this point. Whenever you write a simplified form, F, you should cover all ones. You should cover all ones. You cannot leave any one. Cover all the ones. Now, to cover all the ones, take least possible product terms. Take least possible. Now, you tell me F is equal to, I can take the first one, right? Let me change the color. Yeah, I can take the first implicant, then I covered these two ones. I can take the third implicant and I cover these two. Means, did I cover all the 4 ones? Yes. A bar C plus AB. That's it. This is the answer. The moment you write the answer by using K-map, nobody able to simplify it further. If somebody is able to simplify it further, correct, then we are doing something wrong. Are you getting it? Right? So, let me take one more slide. Let's conclude that. Hmm? So this is F A B C 0 1 0 0 0 1 1 1 1 0. This is how we got it, right? Now what I said is I take this one, this third one, 1, 2. I had 3. For to get one F, I just need 1 plus 3. I don't need a 2. This is the second one, right? So one is, this is A bar C, second one is BC, third one is AB. So the answer is F is A bar C plus AB, right? So now let's define what is the essential prime implicant. What is the essential prime implicant? So an implicant which has at least a single one that is not present in any other prime implicant. This is a prime implicant, okay? A prime implicant which has at least a single one, okay? Now you look at this, you can ask, sir, what is prime implicant? Okay, we'll come back to that. Just understand this. There is something called as prime implicant. We will differentiate it very clearly. Now, if you look at one, correct? This is like this, correct? Now, if you look at this one here in this box, right? This one I'm saying. This one is present in 1 as well as 2 also. But you look at this one present only in 1. You understand? Right? So from this example, I can say that A bar C is an essential prime implicant. But you look at the second one. You look at the second one. Does it have at least a single one? Does it have at least a single one that is not present anywhere else? You look at this one, right? This is present in 1 and 2. You look at this one, this is present in 2 and 3. There is nothing like a single one that is not present in anything else. So these kind of prime implicants are called as redundant. Redundant means repetitive. Somebody is. So redundant prime implicants. Example BC. Right? Minterm 2 is a redundant because it's useless. You are already covering, right? You already covering this one in the 1, this one in the 2. I mean this one in the 3. What is the point of using the second one again? Unnecessarily that will increase the minterms or whatever it is, right? So this is redundant prime. What about the third one? You see, and this is also denoted by EPI, essential prime implicant. This is also called as RPI. Now, what about the third one? Now, yes, this one is present in 2 and 3, but this one is present only in 3. So, it has at least a single one that is not present in anything else. So, third one is also a essential prime implicants. Correct? So, if at all you are writing F, for example, right? If at all you want to write F, what is that you need to do? You need to cover all the ones. So you cannot leave anyone. You need to cover, right? How you should cover? Such that you should get a minimum number of implicants, right? So if I take 1, what is answer? A bar C. Then if I take 3, if I get A, B, right? First thing is you need to give preference to EPIs, okay? First preference, first preference is for EPIs. Unless otherwise you cover EPIs, you will not cover all the ones. Then second preference is you can go for, if anything else is left, then you go for RPI. If anything else is left, correct? Now the question is, first, we need to resolve this. Uh, there is a concept of, can you mute? There is something called non-prime. Okay, I take the same example. 0 1 0 0 0 1 1 1 1 0, right? This is the example. Now we have identified the essential prime implicants. These two are essential EPIs. Then this is RPI. Now suppose if somebody says, what about this? This is also an implicant actually. What about this? What is this actually? If I write in Boolean form, A bar, B bar, C. Hey, can you guys mute? Suraj. Now, this A bar, B bar, C, okay, if you show it to me, what is this? This is called as non-prime. Non-prime. Why it is called as non-prime is there is a bigger implicant which is A bar C. Within that this guy is present. This is A bar B bar C. Now you no need to worry because you are already covering these two in the A bar C. Then what is the point of having this? Okay, that's why this is called as non-prime implicant. This is called as what? Non-prime implicates. So when you are solving K-map, okay, first you need to focus on EPIs, essential prime implicants. Then you look at RPIs. That's it. No non-prime business, right? You don't need to worry because the moment you talk about prime, okay, you are already covering non-primes. So non-primes are useless. So if you look at any standard book, they will confuse you with many things. This is my simple way of explaining. So what is prime implicant? What is we know already. Non-prime implicant is completely present in some other implicant. Okay, I can say an implicant which is completely present in another implicant. Then this is called as non-prime implicant, right? So if you can categorically talk about it, let's say, hmm, this is very important. I'm summarizing it now. We have something called as implicants. What are the example? A bar, B bar C, A bar C, B C, A B. All are called as implicants. Then there is something called as prime implicants. Non-prime implicants. Just now we discussed. A bar, B bar, C is called as non-prime implicant. What is example of prime implicant? A bar C, B C, AB, because these are not completely present in some other replicant, right? Now people may ask, sir, what about RPI? See, RPI partially present in one implicant, partially present in another implicant. It is not completely present in somewhere else, right? So then PIs are divided into two types, like essential prime implicant, redundant prime implicant. We know the definition. Already we have seen it. So example, oh sorry, A bar C, AB are essential, RPIs are BC. This is a categorical discussion. Anything you can take is called as an implicant. Anything you take. In that, they are divided to prime implicants, then non-prime implicants. Then RPIs are divided into two types, RPI and EPI. So let's go back to this problem. Let's solve this problem based on our understanding. No problem, don't worry. If you don't get it also, don't worry. While doing it, you will get it. Next week also we'll discuss more on essential and redundant prime implicants. Now you discuss and tell me. Now you decide. Now you solve it and tell me whether how many essential prime implicants are there, how many redundant prime implicants are there. So option D. Okay, fine. Any other answers? Okay. So how to group it first? Take a group of 8. Possible? No. Group of 4 possible? No. Group of 2? Yeah. Pair, right? I can have this pair. Hmm? Then I can have this pair. Hmm? I can have this pair. I can have this pair. I can have this pair. I'm running out of colors. I can also have this pair, right? Right, because these two are also gray codes to each other, right? Horizontally, I can go, right? I can go horizontally, I can go vertically, not diagonally, not possible, right? Hmm? Now let's name this. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So, number of prime implicants that you have is 6. The question is how many essential? What is the definition of essential prime implicant? It should have at least a single one which is not present in any other prime implicant. This is EPI. Now you have 1, 2, 3, 4, 5, 6. Tell me anything has at least a single one. Now you look at this one, the first prime implicant. Okay, let me change the color, some other color, right? This is present in two implicants, right? Two PIs, 1 and 6. This is present in 1 and 2, right? So 1 is what? RPI. I am writing RPIs here. 1 is an RPI. Now let me go to second one. This is present in 2. This is present in 2 primes, correct? So second one is also RPI. What about third one? Third one is also RPI. What about fourth one? Fourth one is also RPI. What about fifth one? Fifth one is also RPI. people has to go for some other class right now, I guess. So because there are no EPIs, so the answer is 0, comma 6. Sir, what about the answer? How to write S? Okay, that we will discuss in the next class. I'll stop it here and let me know if you have any questions. If somebody want to stay, they can stay and then they can ask questions. Remaining people can leave. Thank you. And we have a lot of problems, okay, on RPIs and all. So many are there. Don't worry. By the time you solve all these things in the next class, we will have a clarity on that exactly. So if you have any question, you can open your mic and then ask. Otherwise, we are good to go. See you in the next week. Okay, Sindhuja, we can discuss about many problems in the next week. Please be there. Like RPI is like if, are you there, Sindhuja? See, you can still see my screen, no? You can open your mic and then talk, okay, so that I can understand. See, if you look at this function, hmm, you have three prime implicants, right? One, two, three. So what is an EPI? It should have at least a single one which is not present in anything else. So one, and this is let's say three, are having at least a single one which are not present in anything else. But if you look at the second one, it doesn't have at least a single one which is not present. Okay, so that's why it is called RPI. Is it clear? 2 doesn't have at least a single, because this one is present in 1 and 2, this one is present in 2 and 3. Okay, so to be qualified for EPI, it should have at least a single one which is not present in anything else, or I can say which is present in itself, nowhere else. That is EPI. Obviously, the other one will be a RPI. If it doesn't satisfy, it is RPI. Okay, Abhay, actually, it is available, na? Okay, Sindhuja, am I clear? Okay, great. So, Abhay, you can see this portal, right? You can see here that gate live mentoring sessions. There you can see this recording link, right? Okay, you can just click on this, you can see. See this? Hmm? Sorry. Okay. Okay, Abhay, am I clear? Yes, yes, my lecture is also there. That's my lecture only. Okay. Okay, Sindhuja, then great. See you guys in next week. Bye bye.